Hello, this is William Huazhan Zhang. Almost everything in calculus stems from one fundamental idea, convergence of sequences. To tackle interesting problems, we must develop a rigorous wisdom. Today, I would like to walk you through this important concept, convergence of sequences. First up, let's define what's a sequence. So a sequence is a function whose domain is the set of all positive integers. Let's use this example. So xn is 1 over 2 to the power n is from 1 to infinity, and then we have three expressions. At least its general form is recursion expression. So now we have an idea of what's a sequence. We can talk about what's arguably the most important definition in calculus, which is convergence of a sequence. So a sequence xn converges to a real number x if for any epsilon greater than 0, epsilon is a real number, there exists a positive integer n such that whenever for any n greater than or equal to capital N, we have the absolute value xn minus x less than epsilon. So this means that limit exists, and then we can write in a common notation as n goes to infinity, the sequence xn tends to x. So let's consider example 2, which we use the same sequence in example 1. So here each term is positive from this general form, we can see that. And also if we plot each point in this list to real line, we can see it tends to 0. And from the third expression, we can see each term is less than its previous term. So it's actually a strictly monotone decreasing sequence bounded below by 0, which means its limit should exist. And from here we guess its limit is 0. So x is 0 here, and what remains to find is the capital N. So here claim limit n to infinity and to the power n is 0. To show is m plus what here is our scratch paper. So minus 0 less than epsilon. To solve this, now we can actually write down our proof, our formal proof. So proof that epsilon greater than 0 be given, we take n, which is greater than number log 2, then for any n greater than 0, we have 1 over 2 to the power n minus 0, which is this. And then by substituting this number to here, after n is greater than or equal to capital N, then we have by using the law of the logarithm, which is epsilon, and this completes the proof, which means the sequence is a convergent sequence. And so if you give me epsilon is 1 over 1024, I will give you n capital N is 10. And however, after you find this capital N is a general form, so every epsilon we can have this to satisfy this condition, and which means the sequence is a convergent sequence.